Let's start. Welcome to week 2 of trigonometry. We're going to be talking about 7.2 today, which is right triangle trig. All right, and right triangle trig is essentially what most people think of when they think of trigonometry. Today we're going to be talking about sines, cosines, tangents, secants, cosecants, cotangents. Eventually we're going to talk about angles of depression and angles of elevation, and talking about applications, finding how tall is that tree and how far away is that lakeside and stuff like that. Okay, so basic trig, we're still in, introductory. Chapter 7 in general is going to be introductory stuff that's kind of, I don't want to say slow necessarily, but it's going to be a review for a lot of people, if not everyone. Some people take trig classes, some people don't take trig classes. I never actually I never actually took a trig class myself. I actually just had trigonometry kind of interspersed in different classes. So whether you've seen it or not, we are going to get into it. Here we go. So we have a triangle right here. We're going to be talking about right triangles for the first 85% of this class. Near the end of the semester, we're going to be doing some trigonometry on triangles that are not right. So that'll be good. Anyway, if we're looking at some angle theta, this opposite side is called the opposite side. The opposite side is the one that is not part of the theta angle. All right. And then over here, we've got what's called the adjacent side. But you might say, well, why is this one the adjacent side? There are two sides that are touching this angle. Well, the adjacent side is the one that is not the hypotenuse. So the hypotenuse is the diagonal of the triangle. Hypotenuse is always the longest side of the triangle, and it's always opposite of the right angle. Okay. And sometimes, sometimes usually you'll see the triangle oriented this way, but there are other, not the adjacent side, the adjacent side. So, the triangle may look a little different, right? Maybe we draw the triangle right here, and maybe theta is like this. Well, this is still the opposite. The opposite is still the one that's not touching. The hypotenuse is still the one that's opposite of the right angle, and the adjacent one is the remaining. Okay, so it doesn't matter how the triangle is rotated. What matters is where's the angle and where's the right angle, and you can do everything based off of that. So the main thing about trig, everyone, be very careful about this. The main thing about trig is that sines, cosines, and tangents are just ratios of sides based on angles of right triangles. And I'm going to be saying this 20 times. The first time, probably going to be meaningless. Second time, probably going to be meaningless. Third time, maybe we'll start having a little bit of meaning. And by the end of the semester, hopefully you understand what the heck sine, cosine, and tangent even mean. So here we go. Most people are familiar with what's called Sohcahtoa, right? And really it's just a mnemonic for remembering what the sine of an angle means. The sine of an angle is its opposite divided by its hypotenuse. The cosine of the angle is the adjacent divided by the hypotenuse. Tangent is the opposite divided by the adjacent. Okay, so we can write those down. Sine of an angle. Sine is nothing by itself. Sine is a function, just like other functions, like the absolute value function, the reciprocal function, the squaring function. Sine is a function. It doesn't make sense without an input to the function. Okay, so sine of an angle is just the ratio of the opposite side. Oh, I'm trying to figure out how I can fix that. I don't want to know there. The opposite side divided by the hypotenuse. It's just a ratio of angles. And likewise, cosine of that angle is going to be the adjacent divided by the hypotenuse, and tangent of the angle is the opposite divided by the adjacent. Sines, cosines, and tangents are ratios of sides. Okay? And so, of course, what you're going to notice, right, is that, well, and actually, I'm not going to spoil it. You may notice some things. You may not notice some things. That's okay. We'll talk about it later on in, I believe today. Yes. So no spoilers, but in about 5 or 10 minutes, you're going to see some interesting relationships going on here. All right. Actually, we're really going to hit it pretty hard. We're going to lay it on pretty thick pretty soon. You'll see it. You'll see it. All right, let's start with example 1. Find sine theta, cosine theta, and tangent of theta. And this is going to look like a long problem, but it's going to go very, very quick. Sine of phi, cosine of phi, and tangent of phi. I don't think we've used the Greek letter phi yet, but phi just kind of looks like this. All right, it's a lowercase Greek letter. The uppercase one looks like that. We oftentimes use this for like the empty set as well. But anyway, phi is usually an angle. And in fact, lowercase Greek letters are very commonly used as angles. You're going to see a lot of theta, a lot of phi, a lot of alphas, betas, sometimes some gammas, maybe a couple other ones as well for angles, but those are the big five. All right, so let's go. I should probably give you the triangle. So it's going to be a triangle where here's our theta, and it's going to be a 3, 4, 5 triangle. These are a very special type of triangles. And phi is going to be this one over here. So all you do is it's really just writing down a lot of stuff, not a lot of computation. But let's start. First things first, sine of theta. Well, we got over here from our good friend Sohcahtoa. Again, so is sine is the opposite over hypotenuse. Opposite hypotenuse. SOH. Okay, so this says that it's going to be the opposite side, which is the 3, divided by the hypotenuse, which is the 5. And that's it. Sine of theta is 3/5. We don't know what theta is yet. Eventually, we're going to be able to use this information to say what theta is. But for now, we don't know what theta is, and it doesn't matter because we're not asked to find theta here. We're just asked what is the value of sine of theta. Okay. Theta is not 30 degrees. I'm sorry. So here we go. Next up, we got cosine of theta. Well, again, cosine, go to your definition, Sohcahtoa. Adjacent divided by hypotenuse. Adjacent is the side touching it. They're 5 and 4 are both touching it. But 5 is the hypotenuse because it's opposite of the right angle. So adjacent's 4 divided by, again, by the hypotenuse, which is 5. And then you can just go really quick. Tangent is opposite over adjacent. Opposite is 3. Adjacent is 4. So that's sine, cosine, and tangent of theta. And now we just do the same thing for sine, cosine, and tangent of phi. So you're going to notice something here. Sine of phi, well, sine of phi, the opposite of phi is different from the opposite of theta. They're different angles. They're going to have different opposites, but the same hypotenuse. Opposite of phi is 4. So sine of phi is 4 over 5. Cosine of phi, again, the adjacent of phi is 3. Hypotenuse is still 5. Wait a minute. Tangent of phi, opposite, which is 4, over adjacent, which is 3. There's a pattern right here, right? Is it a coincidence that sine of phi and cosine of theta are the same, or is there something deeper going on here? And the answer is that it's not a coincidence at all, right? Because sine is opposite over hypotenuse, cosine is adjacent over hypotenuse. Well, the opposite side of phi is the same exact thing as the adjacent sine of theta, and this will always be the same. These are what are known as complementary angles. All right, we're going to get into more about complementary angles later. Anyway, and then there's a special relationship between the two tangents. They are reciprocals. 3/4, 4/3, flipped over. Speaking of reciprocals, though, you might say, well, Jason, there's not just 3 trigonometric functions. There are 6 common trigonometric functions, not counting the inverse trig functions. Where are they? Well, here they're going to make an appearance. So let's talk about the reciprocal functions. All right. Exclamation point. We have a little smiley face because learning about trigonometry is fun. So this guy's having a good time. Guy or gal, I'm not sure. Anyway, here we go. Cosecant of theta. Oh, I never really named these. Let's name these real quick, right? Sine is officially sine. Most people don't know there's an E in the name of sine. Cosine is spelled cosine. Tangent is spelled tangent. There we go. Now we officially have those. All right. So over here, this is called cosecant of theta. And what cosecant of theta is the hypotenuse over the opposite. But I'm going to tell you this right now. 90-something% of people who know math, you ask what cosecant is, they're not going to answer hypotenuse over adjacent. What they're going to answer is saying, well, this is just the reciprocal of sine. Cosecant is the reciprocal function of sine. Cosecant of an angle is the same as 1 divided by sine of that angle. Wow. That's why they're called reciprocal functions, okay? Just reciprocals. And again, that's pronounced cosecant. Well, we have sines and cosines. I told you we have a cosecant, so of course we're also going to have a secant. And that's SEC of theta. And that's going to be the hypotenuse over the adjacent. But again, nobody says hypotenuse over adjacent. And not nobody, but many people don't think about it that way. They think, as you can probably expect at this point, it's just 1 divided by cosine of theta. And again, that is just secant, is how you say it. So the last one, you can maybe guess, maybe not, I don't know, is actually cotangent. And it's spelled cot. Well, that's what the function looks like. And it is the adjacent divided by the opposite. But again, it's really just 1 divided by tangent. And that's called cotangent. Now, if you don't want to think about these as reciprocal functions, if you want to think about these in a more excited way, you say, well, we have Sohcahtoa. Does Sohcahtoa have a cousin? Yes. Sohcahtoa does have a cousin. So, cosecant is hypotenuse over opposite. Any League of Legends players, we got Cho'Gath coming in right here. And then secant is hypotenuse over adjacent. And then cotangent is adjacent over opposite. We got Cho'Gath. I don't know. It's maybe it's his Chinese friend or something. I don't know. Is that racist? I hope not. Anyway, nobody remembers this either. But well, there's a lot of very, very bad things I could say right now. It doesn't matter though. All right, so nobody remembers this either. The whole thing about reciprocal functions is that they are reciprocals of trig functions, all right? Whew. It's getting hot in here. And we'll use these a lot. You don't necessarily have to memorize them. Yes, you have to memorize them, but we're going to be using these so often that memorizing it's really not going to be an issue, I think. And these are the reciprocal functions that we're going to be using a lot. So let's start using them. Start using them with example 2. In example 2, I am asking you find all 6 trig function values of theta. Oh, there's no S there. And again, these trig functions are functions. All right. So our triangle here, let's say, figure not drawn to scale, 5, 12, 13 triangle over here. Come on camera, focus. Oh, it worked. I wonder if that worked with my students in my face-to-face class. Just talk to them like you talk to your camera. All right, so again, here's what you do. You just say, first off, if I were doing this myself, which I am, what I would do is I just write what are all the 6 trig functions and then fill in the blank later. So we got sine, we got cosine, we got tangent, and then we got the reciprocal functions, cosecant, secant, and cotangent. I would just start by listing all of these. Even if you don't know how to find any of these ratios, just write down sine, cosine, tangent, cosecant, secant, cotangent, because that's some partial credit, and we haven't even done any math yet. It's just remembering, what am I asking for? And in general, on any quiz or any exam, if you don't know what to do, write down as much as you do know. I've phrased it this way before. Essentially, most professors don't like this, but essentially BS your way as far as you can go. Write down everything you know, write down everything you think you need to do, and then maybe you're going to get some partial credit. So anyway, sine is the opposite over the hypotenuse. The opposite of theta is 5. Hypotenuse is 13. So 5/13. Cosine, adjacent, is 12. Hypotenuse is the same, 12/13. Tangent is opposite, which is 5, divided by adjacent, which is 12. Okay, and we've already done all the hard work. Because once we find sine, cosine, and tangent, the reciprocal function values are just the reciprocals of these values. So the reciprocal of 5/13 is just 13/5. Reciprocal of 12/13, 13/12. Reciprocal of 5/12 is 12/5. And not exactly drawn straight, but we have all of our answers for example 2. Just like that. All right, so the last thing that we're going to do is talk about special triangles. And this is going to be the most important thing probably of the whole section, because it's going to be extremely useful in future sections. It's going to be extremely useful in future chapters. When we deal with special triangles, this is essentially your salvation. If you understand special triangles, the amount of memorization you need to do in this class goes way down. And I will give you these triangles. So eventually, some people are required to memorize like 30 trig function values or something. If you use these triangles, you don't have to memorize anything. Just use the triangles and it's going to be magical. Okay? So there are 2 special triangles that I'm going to give you. One of them is often called a 30-60-90 triangle, or a pi/6, pi/2, pi/3 triangle. So again, pi/6, 30 degrees, pi/3, 60 degrees. I'm writing kind of small right now. I'll try to write a little bigger for the next one. And there's a really interesting relationship between the 2 sides. There are actually 3 sides of a triangle. There are a very interesting relationship between the 3 sides of this special triangle. If the short side is 1, the hypotenuse is always double the short side's length. So let's say the hypotenuse now is 2. Well, then you could use the Pythagorean Theorem, a squared plus b squared equals c squared, to solve for b, and find that this is actually the square root of 3. So, they're not all nice, but nice enough. Okay? And this is one special triangle. So this, again, similar triangles. This triangle could be bigger. This triangle could be smaller. But these are all the ratios of the different sides. So it doesn't matter how big the side is, right? The sine of pi/6 will always be 1 divided by 2. The sine of pi/6 is always 1/2. Likewise, the sine of 30 degrees, pi/6 is the same as 30 degrees. Sine of 30 degrees is always, again, 1/2. And when we talk about reference angle and the unit circle and different quadrants and positives and negatives, this triangle is going to be very, very handy. So let's make our other special triangle. I'm going to try to draw this one to scale. This triangle is an isosceles triangle. That's a fun word. Isosceles triangle, again, just meaning that 2 of the sides are the same. So this triangle is a pi/4, or 45 degrees, pi/4, or 45 degrees, and this is pi/2, or 90 degrees. And if the short side of here is 1, well, again, it's an isosceles triangle. So this is also a short side with length 1. Pythagorean Theorem, a squared is 1, b squared is 1. You add them together, you get 2, and that equals c squared. Square root both sides, the square root of 2 is our hypotenuse. And again, this triangle can be any size. What matters are the angles. The angles determine the ratio of the sides, which is why we talk about sines and cosines and tangents of angles, because they are just ratios of sides. So let's get into it next time. That's all we're doing for today. Next time, we're going to finish 7.2. And that's probably all we're going to do tomorrow. And then on Thursday, we're going to start 7.3. So again, the homework this week is actually only going to be 7.2. We're starting 7.3 on Thursday, but that's going to be the following week's homework and quiz. All right. Thank you for watching. And feel free to email me if you have any questions. You can also get started on the homework. It's not due for a little bit, but if you want to get started early, it's always a good idea. Anyway, have a good day.